with Contec and the title Cleanroom Disinfectant Residues Management and Mitigation. My name is Tina Jüling. I am a commercial communication specialist at Fisher Scientific, part of Thermo Fisher Scientific. Here at Fisher Scientific, we offer a series of informative webinars to support our customers. These webinars are designed to help you stay updated on our products, improve your knowledge and skills, explore the latest technologies, and connect with experts in the field. If you would like to see upcoming webinars or watch previous ones, you can visit our dedicated webinar webpage. Please note this webinar is being recorded and will be available later on our website. And now I would like to hand over to my colleague Eva, who will explain how the Q&A session will work.
Hello everyone and welcome again to today's webinar. And my name is Eva Albertsson. I'm also a commercial communication specialist here at Fisher Scientific. I will guide you through the question and answer session after the presentation. And you are welcome to ask questions at any time during the webinar. To do so, simply type your questions in the chat box on the right side of your screen. Our expert will do their best to answer your questions during the question and answer session at the end. So over to you, Tina.
Thank you, Eva. So I think we're ready to start the webinar. Today we are joined by Contec's quality manager, Neil Simpson. Neil holds a degree in applied biology and microbiology from the University of Wales. He has over 20 years of experience in contamination control, supporting pharmaceutical, biomedical, and other critical industries. As a microbiologist specializing in chemical disinfection, he has developed clean room disinfectant products and processes worldwide, earning a product design patent. He also helps Contec to establish the European disinfectant manufacturing and secure ISO 9001 certification. And now I will hand over to you, Neil. I wish you all an interesting and informative webinar.
Thank you, Tina. Well, welcome everyone. I'm absolutely delighted you could take the time out of your busy schedule to join me today for the next hour to talk about residues management and mitigation. So with that, we will start the presentation. So really, when we're thinking about disinfectant residues, what are the real topics that we have to keep in mind? Well, we need to know exactly what residues are, why they can be a concern within certain environments, the regulatory aspects, the residues that are left, and how we can actually control those types of residues as well. How do we know what's on the surface? So how do we validate the removal process of residues? Evaluation of those methods used for removal, and some comparison of residue removal methods. So that will form the basis of today's discussion. So really, what are residues in themselves? Well, as a very brief explanation, a residue is any substance that remains on the surface after you've completed a certain process or activity. But as far as clean room residues go, a clean room residue will fall into two distinct categories. Those from the manufacturing processes, so residues that arise from your own manufacturing and production process, and those that will arise from your cleaning and disinfection process. So typically process-related residues can be things like your raw materials, the equipment within the manufacturing area, and then whether you use any particular excipients, media, and even the product you manufacture itself. Whereas for disinfectant residues, these are environmental chemical residues from your clean room disinfectant or your clean room detergent. So really, why are they a concern for us within clean rooms? Well, very easily, the buildup of residues can certainly adversely affect subsequent disinfection. What do we mean by that? So residues themselves on a surface can cover microorganisms, or they can make your next application of disinfectant not as effective and efficient as it should be. We have to think about safety issues. Certain chemistries can cause slippery or even sticky floors, and slippery floors can certainly be a health and safety issue in any environment. corrosion and damage to surfaces. People always think about stainless steel and how certain chemistries may cause corrosion to those. Transfer to product contact surface. So what you don't want to do is actually move your residue, cross-contaminate your residue from one area to another. Aesthetic issues. You don't want people or yourselves looking into your clean room and seeing residues typically on windows, on equipment, on floors, on walls, on ceiling, so any part of it. So it's really how well your clean room looks when being viewed. And there's always the possibility, depending on the type of residue you have, that it could support or aid at least microbial growth. There could be interaction between certain chemical residues, and this can lead to regulatory citation, as residues typically display a lack of control of your process. So thinking about the regulatory side, pharmaceutical companies have been cited in the past for the presence of residues. So a review recently of 62 FDA 483s, and that's what's issued if you're cited by the FDA, showed 37 of these were for inadequate validation of cleaning procedures, 8 were for inadequate validation of the disinfectant itself, and 17 related to residue issues. So 27% of those 62 citations were about residue issues. So again, the presence of residues can be seen as the cleaning and disinfection process is not fully in control. And so for ourselves in Europe, what does GMP Annex 1 2022 tell us? Well, there has been some updates and changes, as you know, from the 2022 version from previous. The reference to cleaning and disinfection has been expanded. The terminology of cleaning replaced with cleaning and disinfection. And of course, this reflects current best practice, that you're looking to disinfect visibly clean surfaces, or you're looking to clean residues away from a surface prior to disinfecting. Now, it doesn't have to be done in that way each and every time. You're trying to make sure that you disinfect visibly clean surfaces. References that cleaning programs should remove residue, disinfectant residues, and the cleaning process should be validated, and it can demonstrate that it removes any residue or debris that could detrimentally impact the effectiveness of the disinfectant agent used. But of course, as Annex 1 typically doesn't, it does not tell you how residues can or should be removed or how to evaluate this particular process. So again, hopefully we can help today as we're going along. So as a brief regulatory overview, USP 1071 does state removal of residual disinfectant should be monitored for effectiveness as a precaution against the possibility of product contamination. So again, we're looking at potential of cross-contamination in that regulatory advice. Annex 1 I've already just discussed. PDA Technical Report 70 also says, procedurally strict cleaning without the use of a sanitizer, disinfectant, or sporicide should be conducted on a routine basis as defined by a written procedure. So there's regulatory evidence that we should be doing something to manage and remove these residues from a clean room environment. And that takes us on to the residues themselves. And one thing that we do know for sure is nearly every disinfectant chemistry used in our industry leaves residues. The only exception to this rule are alcohol and hydrogen peroxide. Alcohol will evaporate from the surface. Hydrogen peroxide will naturally degrade to oxygen and water. All other disinfectants will leave a residue of some type. And the interesting thing is some of these will be worse than others. And also some will be easier to remove from surfaces than others. And again, we'll touch on that as we go through today. All detergents themselves will leave a residue. I've visited far too many facilities that think because you use a detergent, it's going to somehow magically remove residues. To do this effectively, you have to apply a detergent. You have to rinse and dry those surfaces to remove the solubilized residues. And again, there are no currently approved or published methods for assessing the amount of residue on non-product contact surfaces. So there's no standardized way of actually efficiently evaluating how well your residue removal process is being conducted. And therefore, most facilities will conduct a visual test. for residues on non-product contact surfaces. In other words, can we see residues present on the surface ourselves? So we use in our eyes, which are a great tool and device for us to use. We can pick up lots and lots of detail, but that's really what we have at this moment in time. And of course, to try and aid you in this whole process of residue removal, some disinfectants claim they are no or even low residue products. So what does that actually mean, low residue? Well, again, there is no definition or standard of what a low residue clean room disinfectant is. What it might be to one could be completely different to another. Is it 50 ppm, 100 ppm, 1000 ppm? It will vary considerably. However, there are claims made on disinfectant advertising that a disinfectant is either no or low residue. So as I said, when it comes to disinfectant actives that will leave no or low residue, that will be a very small amount: alcohol, hydrogen peroxide. So a quick way of comparing disinfectant residues is to conduct a residue on evaporation test. So this will basically take an amount of water that you've pre-weighed your container. You will add 100 mils of your solution. You will evaporate off the volatile part of that solution and leave with a non-volatile reading at the bottom. So what will be left on the surface once your product has dried. Now, the European Pharmacopoeia does give a criteria for alcohols and hydrogen peroxide as to what exactly you should see left over as a residue. For IPA, that's a maximum of 20 parts per million, 20 ppm. For 96% ethanol, the residue maximum of 25 ppm. And 30% hydrogen peroxide, which of course is either used in VHP or a much lower percentage, for example, 6% used for surface manual disinfection, a maximum of 20 parts per million. And these are generally accepted as clean room disinfectants that leave little to no residue on the surface. So there is no agreed figure for what constitutes or what makes up a low residue disinfectant. So I mentioned residue on evaporation. That gives us our non-volatile residues on a surface. Now the table that you see on screen at the moment is some different products with similar actives. So some different IPA products, some different denatured ethanol products, peroxide, and that's a difference between standard peroxide and accelerated hydrogen peroxide or hydrogen peroxide peracetic acid blends, some different quaternary ammoniums, some chlorine-based products, some sodium hypochlorites, and you can see there's a massive variation in the amount of residue on evaporation on non-volatile residues left, ranging from almost not detectable 0 to 1 for IPA, all the way up to 62,000 ppm for an amphoteric surfactant to 20,000 for sodium hypochlorite. But also interestingly, if you look at some of the same chemistries, depending on the formulation concentration, and other constituent members of the formulation that you have, they can vary significantly as well, from 5,000 for a quat product up to 20,000 for a quat chlorine dioxide blend. So again, you have to keep all these in mind and know your disinfectants. The level of residue can be different for active ingredients, as I've just mentioned, and they can vary significantly down to the formulations. So the concentration of the active ingredient in the product may be the same, but the amount of stabilizers can certainly vary. The amount of any additional preservatives, pH adjusters, odor mitigators, or any other non-active component of the formulation. And even a low concentration of an active ingredient doesn't always mean the residues that are left are different. One active will give, so that the two figures in front of you are the same active ingredient. So a 2,300 ppm active ingredient leaves approximately a 1,400 ppm non-volatile residue, whereas a 600 ppm active of the same product, the same active ingredient, leaves the same non-volatile residue. So let's talk a little bit more about residues and how we can kind of look at them and quantify them ourselves. So So visual appearance, that's very key here. We're saying there's only really a visual method, standardization of determining residues on surfaces. And that's not to say there aren't other methods, but at the moment, visually clean equals clean is something that is used a lot. And we know residues can take lots of different forms, from clear to transparent, to white, to crystalline, to powdery, to sticky, to slippery. There are lots and lots of different appearances depending on the chemistry that you're utilizing and other aspects of the formulation used. So we decided to look at the visual appearance of a disinfectant on different surfaces. So we took a Contec product. It's a sporicidal product based on hypochlorous acid. And we sprayed the product, so we applied via spraying onto coupons of different surfaces commonly found in clean rooms to see if the same amount of residue looked the same on each different surface. And for that, we took stainless steel, I think it was 316 stainless steel, aluminium, high pressure laminate, and a powder coated steel. And so every day for a 4-week period, the sample was sprayed with the same amount on each sample, allowed to dry, and that residue to build up on the surface. Now, what we know from hypochlorous acid is the residue that will build up is a calcium salt, which appears as a white residue. And we know the residue on evaporation for prochlor, so the non-volatile residue it leaves per 100 milliliters is 1,000 to 1,500 parts per million. And what we saw is the same amount of residue on a different surface can look very different. And that's down to the type of surface, the color of the surface, its reflectiveness. So less reflective surfaces tend to show residues far less. The smoothness of the surface. So again, any slightly textured surface shows those residues far less. So all those pictures on screen have exactly the same amount of residue applied, but look very, very different visually. So if it looks very different visually, how can we apply that process of visually clean equals clean? So we decided to take and slightly adapt the test to use the same surface and see how this replicated. So we took highly polished mirrors that we used as a reflective surface to show a residue as well and as easily as possible. So the first method we had was spraying a common sporicide to the center of each surface. We used a silicone ring to contain the amount of residue so it didn't spread too much. It was left to dry. No attempt at wiping the solution was made. And we did this to create a completely worst case scenario where the disinfectant had been left to pool and dry in a certain area several times. The second method we applied was wiping. We took a polyester cellulose wipe and one of those per polished surface. The product was applied via a single wipe down the center of each polished surface twice daily for 12 days. So a total of 24 wipes per mirror. And this really reflects how most people would apply disinfectant products to a surface. They would apply to a wipe or have a pre-saturated wipe and apply to the surfaces. And again, we tried to then quantify the results that we had based on a visual scale. So the qualitative scale we used was 0, 0 being no residue seen or left, and 10 being a large amount of thick, highly visible residue was seen. And again, from the actives that we used in this test, we can see some big variation. So almost easily the worst that we saw was a 5,000 part per million sodium hypochlorite that left just short of a 10. So we had a 9 out of 10 for the residue of the fluid applied by spraying. That dropped to a 5 when it was applied via a wipe. The same, a chlorine dioxide product had a 6 with spraying, but it dropped to a 3 or a 4 when applied by a wipe. And of course, pictures always tell the story a little bit better. So again, these were highly reflective surfaces, so they were reflecting the ceiling or area above the photos. But you can see what we have on screen is the sodium hypochlorite. Left to pool from spraying, you have a large amount of residue that is built up. When it's wiped on, again, it's there in the background. You can certainly see it, but it's nowhere near the amount that we see when it's been applied via spraying. The same for, at the time, a quat biguanide blend, not one we see so much now due to the biocidal products regulations, but we can see a kind of transparent large amount of residue when it's applied by spraying. And again, a lot more difficult to see that residue when it's been applied by wiping on. So what we do when we're wiping on, we're controlling the application of the disinfectants that we're applying to surfaces. The same for a low residue quaternary that we have. Again, you can see it when it's sprayed, you can see it's dried, it's actually gone outside the ring, it actually hasn't been contained within the ring. When applied via wipe, we can not really see the residue on the surface at all. So what does it tell us about residue accumulation over time? Well, residue applied by wiping, each application dried before the next application was applied. That's important. If it's wet, you can actually be having a little bit of mechanical action and removing some of the residue before you apply anew. A total of 6 applications for this particular test was made. Mechanical action and fluid interaction apparent with each application. And it indicates residue application via wiping or mopping, because again, it's just another method of applying to a surface, is incremental and is likely non-linear. So when you apply disinfectant to a surface, it does not dry to the same amount of residue each and every time. So you don't build up 6 exactly the same layers. You build up incremental layers on top, but it can vary considerably. So again, it just makes this whole process quite complex. How do we come to something that's a little bit more achievable? So with these residues, what have we found? Well, we've certainly found the appearance of residue on different surfaces within a cleanroom environment can make the residues look lesser or greater for the same amount, dependent on the characteristics of the surface. So that color of the surface, that texture of the surface, whether it's transparent like glass or whether light is hitting it so you can see residues, those all have a major impact in how well you can see a residue. Highly reflective surfaces such as glass, polished metals will show the residue more significantly, although the amount of residue might be exactly the same. This really means a purely visual check for a residue on a floor might not be sufficient. You might not be able to see the residue well for those reasons I've just mentioned. A glance at windows in a clean room will usually quickly reveal if there's a problem with residues. Windows are always the soul to a clean room. If you can see residues on a window, likely there are residues present on other surfaces. The method of application of disinfectant will always affect the amount of residue created. So if you spray a surface, you'll apply more residue than if you wipe a surface. Depending on the wipe that you use and the saturation of the wipe, that will also change the amount of residue. If you mop a surface, that can vary significantly down to the type of mop, from a sponge mop to a polyester mop and other variations in between. So the visual appearance of the disinfectant on a surface does not always correlate or work out the amount of residue shown on a residue on evaporation test. So again, knowing what non-volatile residues may be left on a surface doesn't always match up with what you see. That brings us on to disinfectant residue removal. So with the exception of alcohol and hydrogen peroxide, as I've already mentioned, all other disinfectants are going to leave some residue. It can be checked with that residue and evaporation test, so you have an idea of the amount of non-volatile residue you may be leaving on a surface. But always, prevention is better than cure. So prevention of the residue accumulation is much better than trying to clean it off afterwards, to remediate that residue. If you allow residue to build up in multiple layers, it's going to be much more difficult to remove than if you had a more active involvement of removing that residue. So stop the residue building up, wipe it to dry if it's still wet on the surface. Again, far more achievable on horizontal surfaces and equipment than on walls and floors. Find an effective methods to remove the disinfectant residue to a visibly clean level. Knowing whether a residue knowing whether a disinfectant leaves a small or large amount of residue does not always equate to how easy it removes from a surface. So a disinfectant that may leave a lot of residue may be far easier to remove from a surface than a disinfectant of a different chemistry that leaves a lower amount of residue. So again, you have to build up that picture of knowing what you're using, knowing the surfaces you have within your facility and how the product looks on those surfaces, and how easy it is to remove from those surfaces, especially over time as well. Some disinfectant residues are easier to remove than others. They can be more free rinsing. They can readily resolubilize in a solution. Others could be sticky, waxy, difficult to remove. Quaternary ammonium compounds are notoriously difficult to remove from surfaces. They're a positively charged active molecule that will attach to most surfaces. So even with alcohol and water rinses, it doesn't always guarantee that you remove the residues from the surface. In fact, most facilities I visit that use a quaternary-based disinfectant are very, very, very likely to have visible residues present. And the surface itself may affect residue removal. Old, damaged, scratched, textured surfaces will be much more difficult than smoother surfaces and newer surfaces. Your choice of cleaning agent. So facilities might use water of appropriate quality. So depending on the grade of clean room, they'll use water ranging from WFI to purified or highly purified water. Leaves no additional residues, will resolubilize most residues on a surface, but may be less effective and could have issues of leaving the surface wet with no microbial action. Alcohol certainly could be more effective in resolubilizing residues. Again, because of its evaporation, it's going to leave no real additional residue of its own. It'll leave the surface dry in the end because it will evaporate. But of course, we have to take into account it's 70% alcohol, there are flammability issues, and there are also exposure limits for using both IPA and ethanol. So we have to be aware that using them over large surface areas like walls and floors could exceed those exposure limits. And then if you have a large amount of soiling or residue on an area, you may need the extra aid of a detergent to remove those levels of residues. So with detergents, detergent is a cleaning agent with wetting and emulsifying properties used to help remove residues and soiling from a surface, hopefully leaving it visibly clean. And I say hopefully leaving it visibly clean because we have to remember to remove that product after it's solubilized the residues. So certainly may be more effective against large amounts of soiling, will penetrate and resolubilize those residues because it reduces surface tension, but it will leave a residue itself that needs removing. You can't just apply a detergent, even by wiping or mopping. It needs rinsing and drying. I always use the analogy of cleaning a car because most people will clean a car. You shampoo the car, you rinse the car afterwards. If you leave it dry, you know you get those little spots over the car. If you want it looking nice and shiny, you have to go around and dry off that area afterwards. And a clean room, or indeed any other room, is exactly the same. And again, choose a detergent that will be as safe on your facility surfaces as possible, one that will have a neutral pH, non-ionic, non-enzymatic. Only really use alkaline or acidic detergents when necessary. If you have a product that is really difficult to remove from a surface or requires the use of an alkaline or acidic cleaner. Does the residue change over time? Now, this is something that we really have to kind of think about because a residue that might be easy to remove after an hour or a day or a week, is that the same after a month or after 3 months or after a year? So does the way in which the disinfectant residue attaches itself to a surface change over time? Just because a disinfectant residue is free rinsing at time point 0 or even after 1 hour or 1 day doesn't mean it can still be easily removed weeks later. And we've carried out work to show that residue that was immediately free rinsing and even up to 3 weeks later could easily be removed, couldn't be easily removed after 4 weeks after application. So we have to bear in mind that time will play a factor on this, and certainly additional layers of residues will also have a factor. If residue removal isn't going to be carried out immediately, the time left between removal stages needs to be validated. You need to ensure that if you're going to clean weekly, 2 weekly, monthly, that it's still going to be effective in removing those residues you have on the surface. So validation of residue removal. So a lab-based residue and evaporation test will give you a nice quantitative result of how much residue a disinfectant will leave. If it's above 25 ppm, because again, the EP, the European Pharmacopoeia, gives level for alcohol and hydrogen peroxide, which is 25 ppm or less, to really state no to low residue. So anything above will be higher than that, and you will need to do further work to determine validation of that residue removal. Confirm whether the residue on a highly reflective surface can be removed with water or IPA. If not, find an appropriate detergent or cleaning agent. If the residue is not to be immediately removed, if you don't have that ability within your facility, or your SOP is for weekly or 2 weekly or monthly, make sure that you actually perform those activities before to show that your residues can still be easily removed from those surfaces. This type of information can also be provided by the manufacturer and can be validated by yourselves as the end user. Validate removal on worst case surfaces when applying using facilities standard operating procedures. And then really preventing that residue buildup. As I said, prevention is absolutely always better than cure. Use no to low residue disinfectants where possible, but you have to bear in mind, no fast acting sporicide. And I would say a fast acting sporicide is something that has a wet contact time to kill bacterial spores of 3 minutes or less. There is no fast acting sporicide that leaves no residue. So wipe to dry or dry with a wiper or mop. If it's still wet on the surface, that depends on the contact time of your disinfectants. If you have disinfectants with very rapid contact times, that may be achievable. On certain surfaces, it can be quite difficult for the remaining surfaces. So for the ones which dry, either weekly or bi-weekly removal with water or alcohol used to resolubilize those residues. And you have to think about any health and safety issues of using alcohols over large surface areas. Set a regime for detergent clean. That might be monthly, that might be quarterly. It really depends on your process. There is no one answer fits every facility. It comes down to the frequency of application, the type of application, the type of product. And all this needs to be linked into your contamination control strategy, risk management, and environmental monitoring plan. Now, we've carried out similar webinars in the past, and we've polled the results from the end users just to get a feel for really what happens within this industry. So what do we know? We've asked, if you use a disinfectant other than alcohol or hydrogen peroxide, do you currently have a residue removal program? Almost 60% said yes, 40% no. From another webinar, we had pretty much a very similar result, 58% yes, 41% no. So we know that really about 60% of users have a residue removal, but 40% don't. 40% are allowing those residues to continually build up on their surfaces. We asked in another webinar, if you do remove your residue, do you wipe to dry immediately after the contact time, have an intermediate removal stage with water or alcohol, leave the residue to build up and remove the routine clean with a detergent, or something else? And again, we saw very similar results, because we saw about 50% plus have an immediate residue removal step with alcohol or water, about 10% wiping to dry, and about 30% leave the residue to build up and remove. And again, from the second webinar that we carried out, we had very, very similar results there. So really, we need to look at quantifying how we can remove those residues from the surface each and every time. So everything up to now has been based on the concept of visibly clean equals clean. Residue is removed. Could we find a better method of assessing residue and residue removal process? What kind of pass criteria, if any, can we apply? Is the residue removal only successful if the residues on the surface are below 25 ppm, or can a higher limit be justified? At what residue level does there start to be a detrimental effect on the disinfectants used? Can we define a low residue disinfectant? So there's an ASTM method out there, which is standard practice for qualification of visual inspection of pharmaceutical manufacturing equipment and medical devices for residue. Can a correlation be found between visibly clean and a quantifiable metric? Can that quantitative method of assessing residues be easy to use and robust for normal use? It has to be something that can be easily carried out. We carried out some work using various methods to try and quantify residue and residue removal. A graduation scale for visual assessment that we've already talked about. We used a haze meter, so a haze meter that measures scattered light on the surface to give us another method of analysis. And then we also looked at fluorescent tracer and image pixel analysis. So that visual estimation, we've already been through those and those pictures. Even slight residue is quite easy to see on a highly polished surface, but it can be difficult to quantify because that quantification will be very operator dependent. What I may grade as a 5, someone may grade as a 6 or a 7 or a 3 or a 4. So it's very user dependent. A haze meter, so a haze meter reading light scattered on a surface, so any residue would change that light scattering. It's fairly easy to quantify, quite objective, but it's time consuming. And even worse, you have to target with a haze meter a very small area. And if you remember from when we were talking about wiping earlier, residue doesn't lay down in a linear fashion. So you really have to know as and where to look for looking at those residues, because it will be in a very haphazard areas within the environment of the clean room. And the results were very inconsistent with regards to visible residues as well. So again, it was something that could have easily been that haze meters are very cheap and easy to use, but it really couldn't give us good, consistent, quantifiable results. We looked at fluorescent tracer and image pixel analysis. This is pretty easy to quantify. So we have a clean surface, we have an applied residue that we can look at the fluorescent tracer, and then we have a white surface that we can use image pixel analysis to determine how well that surface has been cleaned after wiping. We found this very objective. We found a full residue field analyzed with image pixel analysis gives us good, consistent results, and also results that match up to what we can see visually as well. And it can be easily conducted on a wide variety of different surfaces. So what we did with the fluorescent tracer and pixel analysis, initially we used a small stainless steel 304 grade plate with 3 areas with a 5 center image capture area. And as I said, those disinfectant residues applied are very irregular and non-uniform. And due to surface tension and interaction, it can spread on a surface very haphazardly, very indeterminate. So we look for a much larger image analysis area, and that will give us more accurate data on what is actually observed on a surface. So we used a larger stainless steel plate with 18 5 centimeter image capture areas. So each surface that we used, in this case a stainless steel plate, had 18 areas of that place that we could analyze for the residue removal. So we used a fluorescent tracer and image pixel analysis to see if we could see a difference in residue removal protocols. Those 18 sampling locations we used, and 5 replicates per trial. A fluorescent tracer dye was added to a disinfectant, an average residue disinfectant, and applied via wiping. Each application was allowed to dry before another layer was added. Remember, we don't want to be removing some or changing the layers of residue by mechanical action. So we allowed those residue layers to dry, and therefore we know that residue was being applied to those surfaces. And then we compared the following procedures. We looked at a dry residue wiped with a dry wipe, a dry residue wiped with a pre-saturated 70% IPA wipe, a dry residue sprayed with 70% IPA, and then wiped with a dry wipe. Dry residue wiped with a slightly wettened wipe. And then a multi-layer area of residue, so 6 layers of dry residue wiped with a pre-saturated IPA wipe. So those were the 5 different variations that we looked at. We used an accelerated hydrogen peroxide disinfectant that has a surfactant base, so we know we were going to get a good amount of residue building up on the surface. And we used per product a consistent amount of fluorescent tracer dye. All disinfectant residues applied by wiping, except for the multiple 6-time application. All residues were allowed to air dry approximately 12 hours between the residue being applied and the test being run. The wipe used to try to remove the residue was a polyester cellulose non-woven wipe, and it was used half-folded. And then we captured the following data: the original clean surface, the applied residue, the post-wiped or removed residue, and calculated the efficiency of that removal process. What did it give us? Well, we have some graphs on screen that might not be so easy to talk through. So what I will go to is the comparison of residue removal method screen. So on the left, we have dry wiper and dry residue, and a very, very low amount of removal. Doesn't surprise me. All you're really doing with a dry wipe and dry residue is moving it around. So a pre-saturated wiper on a dry residue, we had almost an 80% average removal, which is pretty good. Again, it doesn't surprise me, because when you have a pre-saturated wipe and you apply it to a dry residue, you are resolubilizing that residue, but it's difficult for the wipe to absorb that residue as well. So you're creating a bit of a micro emulsion on the surface when you're wiping. Now, what we saw as the best application method was wetting the residue, so pre-solubilizing the residue and then using a dry wipe. Also, very close behind that was using a slightly wet wipe on the dry residue. That makes sense. A slightly wet wipe will still have some sorbent capacity. It'll still have the ability to absorb and remove that residue from the surface. And then what we found is, even with a pre-sat wipe that was nearly 80% effective with 1 layer of residue, the same pre-sat wiper was only 60% effective when you had multiple layers of residue. So again, we've talked about this as we've gone along. The more layers you apply, the more difficult it's going to be to remove that residue. And you have to take that hugely into consideration. So let's start to think of the conclusions of everything that we've talked about during this discussion. So the use of fluorescent tracer and dye in image pixel analysis to analyze the residue removal efficiency is an effective, repeatable process, and correlates well to what we see in its overall appearance. So what we visibly see correlates well to the results that we have. It matches up quite nicely. There was no surprise that trying to remove a dry residue with a dry wipe gives you a very, very poor outcome. Probably the most common approach is using a pre-saturated alcohol wipe. It's pretty good, up to 80% on a 1 layer of dried residue, down to 60% for multiple layers of dried residue. So it's good, but it's not the optimal way. And that's because it's very difficult for a wipe to both release its solvent to solubilize the surface and absorb that residue at the same time. So, and this is backed up by, if we pre-solubilize and use a wipe, there's more solubilization solution there. But if we use a slightly wetted wipe, that gives far better results, because that wipe has the ability to then absorb that resolubilized residue on the surface onto the wipe itself. The results indicate the most effective and efficient removal of dried residue is accomplished by using that slightly wetted wipe with a dry wiper. Similar results might be obtained when removing still wet disinfectant solution with a dry wipe, because it has not had the time to adhere to those surfaces. So again, using a dry wipe with a full sorbent capacity, a full ability to absorb those residues or the solution that's still wet on the surface into it, will give you a far better outcome. Residue accumulation greatly makes the process of removing residues difficult. The more layers of residue you have, the far more difficult it is to remove those multiple layers. So try where possible to get away from multiple applications of disinfectants before you go through a removal process. And again, what we're going to look at is further work to see if these results are consistent for all types of disinfectant residues. We looked at one type, and that was an accelerated peroxide with a detergent background as well. We want to see if that correlates to all different types of chemistries. So we haven't currently found a method of quantifying a residue easily, robustly, and routinely in the clean room. So we still need to conduct some further work to find out if there is one method that can really match up to what we need. When we can measure it routinely, we still need to define what is the pass criteria. At what residue level does there start to be an effect on the disinfectants used, or risk of carryover of residues onto product contact surfaces themselves, cross-contamination, or if it becomes a health and safety issue. Can we identify the disinfectant itself as low residue when there are so many other factors to take into consideration? The impact of the residue on different types of surfaces and surface texture, the effect of the method of application, so wiping compared to mopping, compared to different types of mops with higher sorbent capacities. Can the residue be easily removed? Is that immediately, or for what time period? Cannot just be based on active concentration, because active concentration doesn't always mean that's what you're seeing on the surface. All clean room disinfectants will dry to a non-active concentration on the surface. What you're removing are the non-volatile residues, not the active product itself. So is a low residue disinfectant exactly what we need? Or is it much better to define it as a free rinsing disinfectant, so a disinfectant that resolubilizes and removes easily from the surface, a much more meaningful statement. And at that point, it brings you to the end of this presentation. Thank you so much for your time and listening. I see we have Eva has joined us on stage here. Hi.
Many thanks, Neil. Very interesting presentation, I have to say. And so now it's time for the question and answer session, and take the opportunity to ask questions in the chat. So the first question I have for you, Neil, it's about IPA. And does the IPA need to be 70% for just solubilizing? Would a weaker one be as effective?
Okay, so 70% is used typically as a disinfectant. It's been used at that concentration for many years. You need water within an alcohol solution to enable its mode of action to penetrate the cell. So for residue removal, it doesn't have to be a disinfectant itself. It needs to be efficient at resolubilizing any dried residues. So it could be a slightly weaker one as well, as long as you're aware that using a weaker solution is not also providing disinfectant activity on the surface as well.
Okay, thank you. The next question, did the residue removal tests with different wipes or mops show one was better than another?
This is something that we need to perform with our wider extra work that we need to do. So we used polyester cellulose in the work that I was describing in the presentation. Now, different substrates or wiper material give different attributes on a surface. So polyester cellulose is a blend of synthetic and natural fibers. The cellulose part can absorb solution, so it's good at residue removal because it has the ability to absorb. Whereas, for example, 100% polyester is a very clean material, but because it's synthetic and naturally hydrophobic, it can repel. So you don't want to be cleaning up spillages or particles with 100% polyester because they'll just be moving things around. So the type of material definitely will have a variation on the outcome of the residue And again, that's something that we and other manufacturers can discuss, is the type of wiper substrate to use that will best remove residues from the surface.
Thank you. Are there any disinfectants that leave an active residue?
Okay, so I think I mentioned during the presentation. So one thing to be aware is all the disinfectants that we use in the cleanroom industry, so whether it's alcohol, hydrogen peroxide, hypochlorite, chlorine dioxide, etc., etc., none of them dry to an active concentration on the surface. So none of them dry to the active on the surface, which is a good thing, because if we had low levels of active present, that could lead to resistance of microorganisms. So they typically dry to the non-active, non-volatile residue, and that's what we're looking to remove from the surface. So if you use a hydrogen peroxide, that will break down to oxygen and water. You won't have peroxide on your surface the next day. If you're using a hypochlorite, that'll dry to a salt, so you'll be removing that non-active salt of the hypochlorite that you've applied. So none of the disinfectants in this industry will leave an active residue.
Okay. So what is the allowable acceptance limit for detergent residue?
We come into the part again, what's the allowable limit for a low or a no residue disinfectant, and it really matches up the same. That there are no guidance as to how much residue you can remove or leave on a surface. The variation in detergents that can be used will have different concentrations, different amounts of non-volatile residues in the formula. So again, it depends on the type of product you're using as to what could be left on the surface. Residue on the brain. Any detergent has to be removed from a surface. So like I did during the presentation, I used the washing a car analogy. If you wash your car, you apply the shampoo, you rinse with water, you have to then dry your car to make it look shiny and clean. If you just leave it dry, you will have spots all over the car and it won't look as good once it's dried. And any clean room surface is exactly the same. If you use a detergent, but you don't rinse and dry the surfaces afterwards, and all a detergent will do is resolubilize dried residues. Those resolubilized residues have to be rinsed from the surface, and then to fully get those surfaces clean, those surfaces have to be cleaned and dried afterwards.
Okay, thank you. We're moving on to the next one, and I think that's the last question we have for today. And what is your opinion on the mixture 70% alcohol, ammonia that you can buy at the supermarket, and water all in one 1:1 ratio?
Okay, so all of my thought processes have been based on a controlled environment. So whether it's a clean room, a controlled, not classified environment. So for those environments, you probably shouldn't be using any supermarket-based formulations for removing any residues within it, because again, they aren't controlled in a way with regards to quality, with regards to potential microbial cross-contamination. And again, the clean room detergents that are available in the market have been so specifically developed to remove the type of low residues that we would see within a clean room environment. So dried on disinfectant residues, etc., etc. They typically aren't harmful. So again, if you're having to get 70% alcohol mixed with ammonia, which will be, a fairly caustic product, dilute with water for a 1:1 ratio, no, it's not something that I would be recommending. There are far more suitable, safer clean room products, or even non-sterile products available on the market to use for residue removal.
Okay, it wasn't the last one. We have another one, another question. Are there any residue that are better resolubilized in water, and then you need to wipe again with XX% alcohol to total clean, or are the alcohol good enough to resolubilize the residue?
So this was from Ida, and I said, Ida, that's an excellent question. So again, I tried to kind of build up this picture as I was talking. So it's difficult. The traditional way of removing residues, especially if they've dried on the surface, has been using a pre-saturated alcohol wipe. Now, the problem with that is alcohol is really good at resolubilizing residues. Wipes are really good, depending on the substrate, at absorbing residues, so a polyester cellulose. The problem with a pre-saturated wipe is it already has its sorbent capacity. In other words, the IPA solvent means that when you wipe a surface, it's releasing IPA, but it's very difficult for a wipe to release a solvent and absorb residue at the same time. So if a residue is dried on a surface, the work that we carried out showed is that pre-wetting the surface and then wiping with a dry wipe. So you could pre-wet the surface with alcohol and then wipe over with a dry wipe is greater than 90% efficiency, whereas a 70% IPA wipe was only given us about 79 to 80% efficiency at removing that residue. Or even if it's water, if you apply water or something to pre-wet that surface and then use a dry wipe afterwards, it's going to be much more effective if the residue has dried, because you're resolubilizing it, then you're using a dry wipe with a full sorbent capacity to absorb and remove that residue. If the product is still wet on a surface, then a dry wipe might be more than sufficient to absorb and remove that residue. So again, it's a slightly different thought process to what most people will have applied in the past, where it's been for any kind of residue, probably even wet or dry, use a pre-saturated wipe. Pre-saturated wipe certainly have an important place, but you have to think of what you're trying to do with that residue. You want to resolubilize it and remove it from that surface.
And that was the last question for today. Thanks a lot. Very good answers, Neil. Very interesting. It's not only to throw off your bench with whatever I have learned today. So over to you, Tina.
Thank you, Eva. So that brings us to the end of today's webinar. But before we finish, I would like to thank all of you once again for joining us. And of course, a special thank to you, Neil, for delivering such an engaging and informative session. Before we say goodbye, just a quick reminder to check our website for upcoming webinars. And if you would like to stay informed about the latest news and future sessions, please follow us on our social media channels. Wishing you a great afternoon, and until next time, goodbye for now.